In the grams to mole conversion assignment, there are 6 basic types of questions. I'm going to show you how to solve each one of these, but realize that when you're looking at the assignment, there might be more questions and some of them might have different molecular formulas for the compounds desired. For here, all my examples are going to use ammonium nitrate, NH4NO3, and all the questions are going to require you to use a molar mass with at least as many significant figures as the data given. All the data given here has 6 significant figures. I want to use at least 4 for my molar mass so that I don't lose any significant figures during my calculations. So let's go ahead and get a molar mass of ammonium nitrate first before we go any further. You notice that ammonium nitrate consists of 2 nitrogens, 4 hydrogens, and 3 oxygens. So we're going to take 2 times 14.01 grams per mole plus 4 times 1.008 grams per mole and 3 times 16.00 grams per mole for the molar mass. This is going to give us a molar mass for NH4NO3 as 80.052 grams per mole. Okay. Because I've gone through and done this additive, we would want to stop at the the second decimal place. So we'd stop at 80.05. I'm going to go ahead and use the 80.052 for all my calculations, just so we have a little bit extra significant figures and we're not going to lose anything to rounding. Alright, so if we look at question type 1, it's going to ask us to calculate the number of moles of NH4NO3 in 64.4 grams of NH4NO3. So we're going to take grams of NH4NO3 and convert that into moles of NH4NO3. As we're looking at this, all we need to have here is the molar mass for our conversion. So we're going to start with the 64.4 grams of ammonium nitrate. And then we're going to set up our unit conversion of the 80.052 grams of ammonium nitrate per 1 mole of ammonium nitrate. We want grams on the bottom because that's the unit that we want to get rid of. So we're going to have the moles on top. So 1 mole of ammonium nitrate. Alright, so type this into your calculator, and rounding to 3 significant figures, because that's the number that we're given here, the 64.4 has 3 significant figures, it's going to have to be 8.804 moles of NH4NO3. Okay, so anytime you're asked to find the moles of a compound from the mass of the compound, this is how we want to set up our conversion factor. Mass on the bottom for the molar mass, 1 mole on top, and plug and chug into your calculator. Right. For question 2, we'll move this up a little bit. We're going to calculate the mass of 0.633 moles of NH4NO3. So here we're going from moles of NH4NO3 to mass of NH4NO3. We still only need to have our molar mass as a conversion factor. So when we set this up, we'll start with a 0.633 moles of NH4NO3. And now we're going to put the mass of our molar mass on top. So the 80.052 grams of NH4NO3 will be in the numerator, while the 1 mole of NH4NO3 will be in the denominator. And this allows us to cancel out the moles as a unit. plugging and chugging this into the calculator, we're going to have 50.7 grams of NH4NO3 to 3 significant figures because we started with 3 significant figures in our moles. Okay, so anytime that you're giving a number of moles of a compound and you're asked to find the mass of that compound, just multiply by the molar mass and have the molar mass, the grams, in the numerator and the moles in the denominator. As we look down here at question 3, it's going to say calculate the mass of 6.70 times 10 to the 22 molecules of NH4NO3. Well, in order to do this calculation, we're going to start with molecules, and then we're going to have to go to moles, and then we're going to have to go to mass in grams. We're going to need two conversion factors now. This conversion factor here needs to be Avogadro's number. The second from moles to mass is exactly like we did in question 2, so we need the molar mass of ammonium nitrate. You'll recall that Avogadro's number is 6.022 times 10 to the 23 molecules, atoms, particles, whatever you want to use, is equal to 1 mole. And of course I ran out of space on the video, so we'll move that over. So remember, this is equal to 1 mole over here. Okay, so if we come back and realign everything, let's start with the 6.70 times 10 to 22 molecules. I'm not going to put in the NH4NO3 just because when we start writing out the molecules it gets a little big and I don't want to take up too much more of this page space. This will be important to make sure that we keep track of the entire unit later on, NH4NO3, if we're interconverting between other species or other compounds. But we'll take our 6.70 times 10 to 22 molecules and divide that by 6.022 times 10 to the 23 molecules from Avogadro's number and set that equal to 1 mole on top. Okay, I'm not going to be a stickler if you abbreviate mole as MOL in your calculations. Just make sure that if you're writing this on the exam, you take the time to just write MOL, but you make sure that you write out molecules as MOLECULES. Alright, so once we get to 1 mole of NH4NO3 on the top, we'll go ahead and multiply by our molar mass, 80.052 grams of NH4NO3 divided by 1 mole of NH4NO3. You plug this into your calculator, you're going to get a number, and it's going to be 8.91 grams of NH4NO3 when we round to 3 significant figures, which would be 2 decimal places here. Remember, with scientific notation, this 0 here is significant because it's a trailing 0. So we have 3 significant figures here in our number of molecules. Alright, so let's go ahead and look at number 4. Number 4 is now asking us to calculate the number of molecules of NH4NO3 in 4.75 times 10 to the negative 22 grams of ammonium nitrate. Alright, so we're going to start at mass of ammonium nitrate, and then we have to convert to moles of ammonium nitrate, and then we have to convert into molecules of ammonium nitrate. Alright, so this is the exact opposite process of what we just did in question type 3. So what we want to do is go ahead and run this. So we'll start with the 4.75 times 10 to the negative 22 grams of NH4NO3. We're going to use our molar mass. We'll put 80.052 grams of NH4NO3 in the bottom and 1 mole of NH4NO3 on top. And then we're going to have to multiply by Avogadro's number. We'll put 1 mole in the bottom of NH4NO3 and 6.022 times 10 to the 23 molecules on top. Plug this into your calculator, you get 3.57 molecules of NH4NO3. Okay. So with this question here, just remember we're doing the exact opposite that we did in question type 3. Let's look at the last two types of questions that we can have. Question type 5, how many grams of hydrogen are in 12.38 moles of NH4NO3? Okay, there are two ways to solve this question. I'm going to show you one that will be the easiest for you to start with. So we're going to start with moles of NH4NO3 because that's where our starting point is. We're going to convert that into moles of hydrogen, and then we're going to convert that into mass of hydrogen. Now if we look at the formula here, for every 1 mole of NH4NO3 there are 4 moles of hydrogen present because there are 4 hydrogen atoms per every atom of NH4NO3. And if we have a mole of NH4NO3, that means we have 4 moles of hydrogen. So we'll start with the 12.38 moles of NH4NO3. Convert that into moles of hydrogen. So 1 mole of NH4NO3 into 4 moles of hydrogen, and then multiply by the molar mass of hydrogen, which is 1.008 grams of hydrogen per 1 mole of hydrogen. If we look back here, the moles of NH4NO3 cancel out, the moles of hydrogen cancel out, we end up with mass of hydrogen. Plugging and checking this into our calculator is going to give us an answer of 49.9 grams hydrogen. Yes, please note that this question does give you 4 significant figures. Your answer should be to 3 significant figures. Because every answer in my homework sections are typically 3 significant figures. Alright, question 6. How many moles of oxygen are in 37.4 grams of NH4NO3? Okay, this is almost the exact opposite question that we've seen in type 5. Here we're going to take the mass of NH4NO3 and convert that into moles of NH4NO3 and then into moles of oxygen. Okay, the first one is going to use the molar mass conversion. The second one is going to use the ratio. For every 1 mole of NH4NO3 there are 3 moles of oxygen. So let's go ahead and set this one up. 37.4 grams of NH4NO3. There's 80.052 grams of NH4NO3 per 1 mole of ammonium nitrate. And then for every 1 mole of ammonium nitrate, there are 3 moles of oxygen. Alright, so let's double check. Mass of NH4NO3 cancels out, moles of NH4NO3 cancels out, and we're going to end up in the units of oxygen, moles of oxygen. And if we look at that, that's going to take our calculator out. We're going to end up with 1.40 moles of oxygen. So that's how we're going to go through and do all those calculations for the gram to mole conversion assignment.